Hi friends, welcome back to our YouTube channel. Today we have to discuss about example problem on Kruskal's algorithm in discrete mathematics and graph theory course, data structure course, design and analysis of algorithm course. The given problem is find the minimal spanning tree for the following graph. So this is the given graph. The first step for constructing the minimum cost spanning tree in Kruskal algorithm is arrange all the edges in the increasing order of their weights. Okay. So I am taking first column as edges, second column as weights, the third column as accept or reject. First I am taking this edge. So V1 to V3, its weight is 3. Second one is I am taking V1 to V2, its weight is 4. Third one is V2 to V5, its weight is 4, and fourth one is V1 to V5, its weight is 7. Next one is V2 to V3, its weight is 8. Next one is V1 to V4, its weight is 10. Next one is V2 to V4, its weight is 12. Next one is V4 to V5, its weight is 12. Next one is V3 to V4, its weight is 15. Next one is V3 to V5, its weight is 20. Okay, in this way we have to arrange the edges in the increasing order of weights. Now this graph contains 5 vertices and 10 edges. Among that 10 edges, which edges we have to use in the spanning tree, which edges we have to remove in the spanning tree, that can be shown from second step onwards. Now we can go for second step. In step 2, initially the spanning tree is empty like this. Now we have to take the minimum cost edge that can be added to the empty spanning tree without forming a cycle. If any cycle is not formed, we have to accept this edge. If any cycle is formed, then we have to reject that edge. Here we have to mention either this edge is accept or reject. Now I am taking the minimum cost edge, that is V1 to V3. Its weight is 3. Now it can be added to the empty spanning tree. So V1 to V3. So its weight is 3. After adding this edge to the empty spanning tree, there is no cycle is formed. So that we have to accept this edge. After accepting this edge, minimum cost of this spanning tree is 3. Next we can go for step 3. In step 3 we have to mention previous edge, its cost is 3. Now next I am taking the next minimum weight edge, that is V1 to V2, its weight is 4. This edge can be added in the step 3 after adding any cycle is formed or not. If any cycle is formed, we have to reject that edge. If no cycle is formed, we have to accept that edge. So V1 to V2. So V1 to V2. So there is no cycle is formed, so that we have to accept this edge. So after adding this edge, so minimum cost of the spanning tree is, so 3 plus 4, that is equal to 7. Next, we can go for step 4. In the step 4, we have to consider this edge, whether it can be added to the spanning tree or not. V2 to V5, next minimum weight edge, that is 4. Its weight is 4. So V2 to V5. After adding this edge, any cycle is formed? There is no cycle is formed after adding this edge V2 to V5. Its weight is 4. So that we can say that this edge is accepted. Because after adding this edge into the existing spanning tree, there is no cycle is formed. So after adding this edge, minimum cost of the spanning tree is three plus 4 plus 4. 3 plus 4 plus 4, that is equal to 11. Next the minimum weight edge is V1 to V5. V1 to V5. Its weight is 7. Whether this edge, after adding this edge into the existing spanning tree, whether it forms a cycle or not. So V1 to V5, its weight is 7. So V1 to V5. After adding this edge V1 to V5, so a cycle is formed. V1 to V5, V5 to V2, V2 to V1. So that we have to reject that edge. Why we have to reject this edge? After adding this edge into the existing spanning tree, it forms a cycle V1 to V5, V5 to V2, V2 to V1. So that we have to reject that edge. Okay. Next, we have to go to next minimum weight edge is V2 to V3. Its weight is 8. We have to check whether this edge forming a cycle or not, that can be added or into the existing spanning tree. So V2 to V3. So here this is V2, this is V3. After adding this edge V2 to V3, it forms a cycle V2 to V3, V3 to V1, V1 to V2. Okay, so that we have to reject that edge. Why we have to reject that edge? After adding this edge into the existing spanning tree, in step 4, it forms a cycle. So V2 to V3, V3 to V1, V1 to V2. Okay. So there is no change in minimum cost of the spanning tree. Next we can go for next minimum weight edge is V1 to V4. Okay. After adding this edge, the existing spanning tree becomes a cycle or not. We have to check in step 5. Okay. So before going to step 5, whatever the spanning tree is there in step 4, that I am writing here. Okay. Next, V1 to V4. So V1 to V4. After adding this edge V1 to V4, so there is no cycle is formed. Its weight is 10. so that this edge is accepted. Because after adding this edge into the existing spanning tree, there is no cycle is formed, so that we have to accept that edge. After adding this edge, minimum cost of the spanning tree is 3 plus 4 plus 4 plus 10. So that is equal to 21. Okay. Next we can go for next minimum weight edge is V2 to V4. V2 to V4. Its weight is 12. After adding this edge into the existing spanning tree, V2 to V4, it forms a cycle. V2 to V4, V4 to V1, V1 to V2. Okay, after adding this edge V2 to V4, it forms a cycle as V2 to V4, V4 to V1, V1 to V2, so that this edge is rejected. Next one. The next minimum weight edge is V4 to V5. Whether after adding this edge, whether it forms a cycle or not, we have to check. V4 to V5. So V4 to V5. After adding this edge V4 to V5, it forms a cycle. V4 to V5, V5 to V2, V2 to V1, V1 to V4. Okay, so that we have to reject that edge. Okay, after, once again I am telling, after adding this edge V4 to V5, it forms a cycle V4 to V5, V5 to V2, V2 to V1, V1 to V4. So that we have to reject that edge. Next we can go for another minimum weighting edge is V3 to V4. Its weight is 15. After adding this edge into the existing spanning tree, whether it forms a cycle or not. V3 to V4. So V3 to V4. After adding this edge V3 to V4, it forms a cycle. V3 to V4, V4 to V1, V1 to V3. So that we have to reject that edge. Next. What is the next minimum weight edge? V3 to V5. Its weight is 20. After adding this edge into the existing spanning tree, whether it forms a cycle or not. So V3 to V5. So V3 to V5. V3 to V5. After adding this edge V3 to V5, it forms a cycle as V3 to V5, V5 to V2, V2 to V1, V1 to V3. Okay. Cycle is formed, so that we have to reject that edge. Once again I am telling, after adding this edge into the existing spanning tree V3 to V5, V3 to V5, it forms a cycle as V3 to V5, V5 to V2, V2 to V1, V1 to V3. So that we have to reject that edge. Okay. Next, all edges are completed. So that we have to stop the construction of spanning tree. The final minimum cost spanning tree is this one. Okay, so that is the minimum cost spanning tree is this one and its cost is 21. Whether it is correct or not by checking two conditions. The first condition is after constructing the spanning tree, how many number of edges are present. So that is the formula is n minus 1. Okay, how many number of edges that are exist in the final minimum cost spanning tree. For that we have to use this formula. So n minus 1, where n is nothing but number of vertices. How many number of vertices are there? So 5 vertices are there. So 5 minus 1, that is equal to 4. 4 edges are present in the final minimum cost spanning tree. That is first one, second one, third one and fourth one. So this condition is satisfied. Okay, 4 edges that are present in the final minimum cost spanning tree. That 4 edges are this one. First one, second one, third one and fourth one. That means whatever the edges that we are accept, so that are this edge, this edge, this edge and this edge. 1, 2, 3, 4. 4 edges are accepted. Next, second condition is how many number of edges that are removed from the given graph to get the final minimum cost spanning tree. So that formula is m minus n plus 1. How many number of edges that are to be removed from the given graph to get the final spanning tree. So where m is nothing but number of edges, n is nothing but number of vertices. How many number of edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 edges. Minus how many number of vertices are there? So that is 5 vertices. Plus 1. So 10 minus 5, 5 plus 1, that is 6. So 6 edges we have to remove to get the final spanning tree. So what are the edges that are removed? So this is the first one, this is the second one, this is the third one, this is the fourth one, this is the fifth one, this is the sixth one. Okay, how many number of edges accepted is n minus 1 formula. How many number of edges that are removed? The formula is m minus n plus 1. Okay, so in this way we have to check whether the final minimum cost spanning tree is correct or not. Okay, so this is the procedure we have to follow for constructing the minimum cost spanning tree. I hope all of you understanding this video. If you facing any doubts, please put your doubts in the comment section. I will try to clarify your doubts. I am giving the DA playlist, DMS playlist and a data structure playlist in the comment box. We have to use that playlist links for better understanding of the entire subject. If you really understanding this video, please share this video to your friends, classmates. After subscribing my YouTube channel, so DIVVELA SRINIVASA. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. Thank you one and all for watching this video.